Hey guys, so this is the Math 094 Exam 3 review video, and this one is over, we had properties of exponents, which is these first few sections, and then addition, subtraction, multiplication, division with polynomials. So those are the skills we're looking at. So starting with kind of the multiplication, division with exponents. So these are our properties. Property 1, this is when we're multiplying two things with exponents. It's common base, we add the exponents. Property 2 is another kind of workhorse one where if we're raising something to a power, we multiply the exponents. So when we multiply, we add. When we raise to a power, we multiply, and those get mixed up a lot. Property 3 isn't very exciting. It's just showing you raise everything to the exponent. Property 4, this one gets messed up a lot. This is if I have something to a negative exponent, then I write it as 1 over that with a positive exponent. Likewise, if I have a negative exponent downstairs, I can bring that up, so you can essentially think of that as a to the x over 1. So negative up, bring it down, it's positive. Negative down, bring it up, it's positive. Property 5 is the other one that's gets used a fair bit, and this is when we're dividing, we subtract exponents. So when we multiply, we add. When we divide, we subtract. So addition, subtraction go together. Same way multiply and divide go together. Property 6 is just saying the same thing as property 3, not very exciting. And then a to the 0, anything to the 0 other than 0 is 1. So that's that last one. So let's see how those work in some examples. Okay, and when we saw this originally, 401 was multiplication, 42 was division, and I just sort of blended these together because the properties are really kind of all one big idea. So this first one, let me rewrite this so it's a little bit bigger. X to the negative fifth, x to the sixth, x squared x. So the couple of things to remember, so we're multiplying, so we're adding exponents, and the other thing is that there's this little lone x here on the end. There's an invisible 1 right there that often gets forgotten. So if it helps you to write the little 1, write the little 1. And we multiply, we add the exponents. This is going to be negative 5 plus 6 would be 1, plus 2 plus 1 should be x to the fourth. The next one, so this is a negative 8x to the seventh squared. I think, again, I'm going to write it a little bit bigger, just for people watching on their phones. So this gets messed up too, the sign. So think of this squared is really meaning we have two of these things right here. So we have two negative signs. So it's negative 8 times negative 8. So that's going to be a positive 64. And then here we're raising to a power. So that's going to be multiply. So x to the 14th. And anytime we raise a negative like this in parentheses to an even power, it's going to come out positive. So number 3 is negative 2ab to the fourth cubed. So this time we have an odd power, so that's really negative 2, negative 2, negative 2. So it's going to be negative 8. So when we raise a negative to an odd power, we get a negative value. This is a little invisible 1, so 3 times 1 makes a cubed, and 3 times 4 makes b to the 12th. Okay, number 4, this is x to the 5th to the 3rd. So we're going to multiply the 5 times 3 and get x to the 15th. And then where there's nothing here, there's an implied times. So we're thinking multiplication in there. And then x cubed to the 7th, so 3 times 7 for x to the 21. So we raised to a power, so we multiplied, and now we're multiplying, so now we'd have to add. So we go 15 plus 21, and that would be 36. This next one, let's see, I'm going to write it a little bigger. So we're going 2 cubed, so 2 times 2 times 2, careful not to get 6, that'd be 8. And then x to the 4th cubed, so that's 4 times 3 would be x 12. And again, in between here where there's nothing, it's an implied multiply. So 2 cubed again is going to be 8, and then 5, x to the 5th cubed will be x to the 15. 8 times 8, 64. And then 12 and 15 would give us a total of 27 x's. And then this one, so x, we got 2/3 x to the 4th y cubed. So 2 cubed is going to be 8. And then the 3 is also cubed, so that's going to be 27. It's just like having 2/3, 2/3, 2/3. X to the 4th cubed, x to the 12th, and y cubed will be a y cubed. Okay, I rewrote these so they're a little bit, hopefully, easier to see on a small screen. So this next one, we got a negative exponent, so it's squared, so it's going to be positive because it's like negative 5, 6 times negative 5, 6. So that'd be 25, and then 6 times 6 would make 36. And then x to the 4th squared makes x to the 8th. Again, no more negative because that was squared, so there are two negative signs, so it makes a positive. So these next two get mixed up a lot. This one right here, this is going to be a negative number. And this one right here is going to be a positive number. And the reason is because they're not the same thing. This one means negative 1 times 2 times 2 times 2 times 2. So the negative out front, because it's not in parentheses, is just, it comes after the exponent. So it's like we're going 2 to the 4th and then making it negative. So there's only one negative sign there, so that would make this one negative 16. This one, on the other hand, is literally 4 negative 2's. So we'd have 4 negative signs, and that will make this one positive 16. 19x to the 5th to the 0. Anything to the 0, even if it's a bunch of stuff, is 1. So that's that one. And then these two are kind of like this, easy to mix up. So here, the negative 2 is working on everything in the parentheses. So this is going to be like this. So everything in those parentheses is going to drop down, and then this is going to be a positive 2 off of property 4. And then when I clean that up, I'm just going to square it. That's going to give me a 16x squared. Here, it's like this one. This 4 isn't being worked on by the 2. Because like if this was like 4x squared, if you put some number in here, you go that number squared and then multiply by 4. So the 4 is totally separate from that exponent, which means when I go to simplify this, it's just going to be 4 over x squared. So they look kind of similar, but different deal. Okay, so these next three, they're 13, 14, and 15. I didn't write down the numbers. So we can do these one of two ways. We can do the subtraction property first, which is property 5, or if we're dividing, we subtract the exponents. So let me show that one. So if we have x to the negative 5 and then minus 7, that's going to give us x to the negative 12. And then I'd have to use property 4 to write that with the positive exponent, because remember, we want to always write stuff with the positive exponent. So I get 1 over x to the 12th. So that's one way. The other way is to use property 4 first. So if I have this, then this negative 5 should really be down in the denominator. So this is going to be 1 over x to the 7 was cool because it's positive where it is, and then x to the 5th. And then here I would add because they're multiplying, and I get the same x to the 12th downstairs. I'll do this one, same thing both ways. So x to the negative 8 and then minus a negative 14. So that would be x to the minus would be plus, so negative 8 plus 14 would be positive 6. If I think of it the other way, so for me, I would rewrite these with positive exponents. So the x to the negative 14 should be x to the 14 up top, and then x to the negative 8 up top becomes x to the 8 downstairs. And then it's kind of like the subtraction thing. I guess in my brain, I think of it more as a cancel. But just if I have 14 up and 8 down, if I canceled out 8 of them, I'd have 6 left up top. So x to the 6th. This one we're going to go x negative 16 minus a negative 11. And that's going to give us negative 16 plus 11, so that's still x to the negative 5th. And I can't leave a negative, so I have to write it as 1 over x to the 5th. And then the other way, so again, I'll rewrite the 11 up and the 16 down. And then I don't really, again, think of it as a subtract. I think of it more as a cancel. So I'm knocking out 11 of these, which would leave 5 downstairs. So I'm not worrying about the sign. I'm just worrying about kind of where I have more is where they would end up. For instance, like if I had x squared over x cubed to the 5th, say. So I have 2 x's and 3, 4, 5 x's. If I cancel 2, I have 3 left. So that's kind of what I'm visualizing, so I'm not really getting hung up on is it positive or negative. I'm just thinking more position. Okay, for number 16, I just rewrote it a little bit bigger here. So 5 raised to the 6, that's give us x to the 30th, and then that's over x to the 18. And then if I do subtraction, I get 30 minus 18, or x to the 12th. Or I could just think of cancel x to the 12th. For number 17, so this is x to the 4 times 2 would be 8. And then 7 times 4 would be 28. So this is x to the 8 minus 28. So that's going to be x to the negative 20, or 1 over x to the 20th. Again, you can just think of it as a cancel, and then it just kind of seems like 1 over x to the 20th if I have 8 up and 28 down. Okay, so this is 18x to the 10th, and then over x squared to the 4th, so 2 times 4 is going to make x to the 8th. And then you can think either subtract, so x to the 10th minus 8 would be x squared, or kind of cancel, same thing, x squared. This one is, I'm just going to rewrite it so you can kind of see the negative signs. So negative 2 times negative 2 will make x to the 4th, and then negative 2 times 6 is going to make x to the negative 12. And then if I do property 5 first, that would be x to the 4th minus a negative 12, and that would be x to the 16th. Or if I think of as property 4 first, I'll just come down here with it. X to the 4th, this 12 should be up top, so it becomes x12 or x to the 16th. So whichever works better for you. Okay, so this one's number 20 again. I just rewrote it a little bit bigger. X to the 8th, negative 3 times 3, so that's x to the negative 9. And then from there, I could just bring the 9 up. X to the 8, x to the 9, and get x to the 17. Or I could have thought of it as x to the 8 minus a negative 9, same 17. Number 21, I'm just going to multiply all of these and see where that gets us. So this will be x to the 12th. And let's see, negative 2 times 5, so that's x to the negative 10, and over x to the negative 9. So I could do a couple of things. I think I'd probably put those together and make that x squared over x to the negative 9. I could bring the negative 9 up in the same step, or I could think of it as subtraction, so 2 minus the negative 9, and get x to the 11th that way. Or like I said, I could think of it as this, and then same x to the 11th. Okay, section 4.3 was operations with monomials. And so it's really using all those same properties. They're just kind of, now there's x's and y's, so we just have to be careful to keep x's with x's and y's with y's. So this is all multiplication, so we just go negative 3 times negative 3 would be negative, or positive 9, and then times 2 for 18. And that's x to the 3rd, x to the 2nd, x to the 5th. So 3 plus 2 would be 5, plus another 5, so that's x to the 10, and y to the 4th, y to the 5th, so that makes y to the 9th. For this one, so I think I'm going to rewrite this. So this 20, I'm going to write that as 4 times 5, and then x to the 4th, y to the 13th. And this negative 25, I'm going to write as negative 5 times 5. And it's supposed to be a 9. Yeah. So the 5s cancel, and you're welcome to do that in your head, but just sometimes you'll have some trouble simplifying fractions. So because that's one that reduces out, the negative down in the denominator looks a little funny, so I'm going to put it in the numerator, but it means the same thing. And then I'll just do my division bar over 5. So we have 4x's up, we have 9 down. This is where I really like the cancel idea, so that'd be x to the 5th downstairs. And then 13y's up and 12 down, so that would leave me a y up top. Okay, so I think I'll put these together and then reduce. So 4 times 9 is going to be 36. X to the 6th, x to the 19th, so that's 6 and 19 is 25. And that's over 48. X to the 20th. If we want to think of kind of dividing these up, it would be a 3 times 12 and a 4 times 12. And 12 is the biggest thing, divides into both. and then x to the 25th, x 20. So I knock out those 12s, and I'm left with 3/4. You can write it 3x to the 5th over 4, or 3/4 x to the 5th. This is the other way. And both of those are totally right. So I think I'll do the same thing over here, kind of group everything up first. So this is going to be 5 times 8 is 40. X to the 6, x to the 3rd, so x to the 9. Y and y to the 5th, so y to the 6th. And then 3 times 10 is 30, so that's going to work out pretty nice. 9 and x to the 1st, x to the 10th, x squared, x cubed. I can knock out that factor of 10, so that's going to give me 4/3. Do that. And then up top, we got 9 x's downstairs, we have 10, so that's going to be 1 downstairs. And for the y's, I have 6 up and 3 down, so that will leave me 3 up top. Okay, I just rewrote these so we can see the exponents a little bit better. So here, the numerators to the 3rd, denominators to the 2nd, so I have to treat these as 2 separate problems for now. So 2 cubed is going to give me 8. Negative 1 times 3, so x to the negative 3rd. And then 6 and 3, y to the 18. And then 4 squared is 16, 2 squared, or x squared squared, x to the 4th, and then negative 7 times 2, so that's going to give us y to the negative 14. And then you can do these as a couple of subtraction problems, or for me, actually before we do that, let's go 8, and the 16 is a 2 times an 8, so let's knock out those 8s. And that will get us just a 2 downstairs. And then the x to the 4th and the y to the 18th are fine because they're positive. It's these other two that are a little bit of trouble. So I'm just going to bring the x cubed down and the y to the 14th up and rewrite them with positive exponents. And then I can just combine. So that would be 32 over 2x 4 and 3 to the 7th. So for this one, so it's another one where I can cancel another 8 and 16 actually. So I'm just going to make this a 2. And again, I think I'm going to rewrite this with a positive exponent. It's going to be this big old thing. And you can also kind of just combine as you go. I'm just going to do that. That's going to be so much easier to look at. So I'm going to have a 2 downstairs. And then bringing this x to the 5th should be downstairs. That's going to give me with those 6, x to the 11th. And then bringing the y to the 1st down, negative 1 downstairs because of the negative, so that'll give me y to the 4th. So it's much easier if you just kind of put them together. And then I just have to raise all this to the 4th. And if you just were like, what just happened there? You could totally do x negative 5 minus 6, get x to the negative 11th, and then drop it down. Negative 1 minus that 3 would give you y to the negative 4 and drop it down. I just find it easier to drop these down and combine is pretty much what I did. So then raising it to the 4th, 1 to the 4th is still 1. 2 to the 4th is 16. 11 times 4, so that's x to the 44. 4 times 4, so that'll be y to the 16. Okay, 4 was a really short little section. It was addition and subtraction of polynomials, and we've really kind of been doing that since chapter 1. So this is just combining like terms. So here I have 9x squared and negative 2x squared, so that's going to leave me 7x squared. Negative 3x plus 5x, so that'll be 2x. And negative 7 plus negative 10, so that's negative 17. And then this one's a subtraction. So you don't have to rewrite it, but I'm going to show it that way just because I think it's good. I'm going to slip down here so I have a little more room. And then this minus, I'm just going to distribute it. So minus 4x cubed minus 2x squared minus x and then positive 9. So it just flips every single sign. And then we just go through and find our like terms and put them together. So 11 minus 4 should be 7x cubed. I have negative 8x squared and then negative 2x squared. So putting those, I get negative 10x squared. I got a negative x right there, and then 7 and 9 makes 16. Okay, so this problem, I just kind of wrote it bigger so you can see this on a smaller screen. So all we're doing is multiplying coefficients together, x's together, y's together, and it's a distribute, right? So it's going to 1, 2, and then 3. So negative 3 times 3 makes negative 9. X squared, x cubed is x to the 5th, because remember we're adding because we're multiplying. And y times y would be y squared because of those little invisible ones. Invisible 1 plus invisible 1 makes visible 2. Negative 3 times negative 6, that's going to be a positive 18. And then x squared, x to the 4th, and y squared for y cubed. You can also just think of it counting them up. You got 1, 2, 3 y's, 1, 2, 3, 4 x's. Negative 3 times positive 7, so that's negative 21. No x's, so just this x squared out here, and then y to the 3rd, so y to the 4th. And I'll rewrite this one down here. And so this is just a FOIL. So we do our first 5x times 3x, 15x squared. Our outer 5x times 5, so 25x. Inner, so negative 6x, and last, negative 10. I don't love the FOIL thing again, so I just think of it as distributing this one, and then distributing that one. So that way if there's a third thing here and it doesn't spell FOIL, you understand it's basically just two separate distributes. And then we have a couple of terms, we'll put those together. 15x to the squared, x squared, and then plus 19x minus 10. So this is going to go 2x times x squared, so that's 2x cubed. 2x times negative 2x, so negative 4x squared. 2x times 3, so that's going to be 6x. And then 3 to all these, so 3x squared, 3 times 2 minus 6x, 3 times 3 for 9. And then collecting like terms, I will get, let's see, so x cubed, that's the only one, 2x cubed, minus 4 plus 3, so minus x squared, plus 6 minus 6, those just cancel, and plus 9. So this one I'll bring down here. And what I would do is I'd put two of them together first. And I'm going to do the second two just because I like multiplying two things by three things instead of three things by two things. And it's just my dumb little preference, so that's the way I'm going to do it. So x times x, x squared. On the outside we get x, on the inside we get minus 2x, and then minus 2. Definitely put those together so that you don't do two extra distributes. So I'll rewrite this as x squared minus x minus 2, and now we've really reduced it to this problem. So I'll go through the rest quickly since I just did it up here. So this is just all going to get x bigger, so that'll be x cubed minus x squared minus 2x. And what I just did there was I just thought, okay, this I'm multiplying by x, so everything's x bigger, so that's how I can do that kind of fast. And everything's just going to be 4 times, so plus 4x squared minus 4x minus 8. And then collecting my terms, x cubed minus x squared plus 4x squared, that is plus 3x squared, minus 2x minus 4x, that's minus 6x, and minus 8. Okay, so these are the ones people do terrible on the test, the special products, and they're hopefully they're either really easy or it's like you think you know what they do and then you don't. So this first one, the answer is absolutely not y squared plus 49, and that is such a common error. I'm going to do this one out by FOIL just to remind you why it's not y squared plus 49. So y times y squared. Y times 7, that's how come, 7y. And then on the inside I get another 7y. On the outside I get 49. So there is a y squared and a 49, but in between them needs to be a 14y. And so that's what you're trying to make sure you don't mess up and just think that it distributes, because it's not legitimate math. Okay, so the other way to do this is using the special product formula, which was the goal of this section. Special products end up helping you in Chapter 5 in a couple of places, and you'll see this little chunk of math all over Math 95, and you'll be happier if you're good at this, because it will make stuff way easier. So what we do is we just follow the formula. For me, I think of it almost more of a pattern, so I just think of it as a times a, so whatever's up front, y times y squared. And then it's 2ab, so I just think this 2 isn't this 2, totally different 2, but I just use it as sort of a visual, 2 times a times b. So 2 times y times 7, or you can think of it as 2 times 7 times y, and it actually usually comes out nicer, but 14y anyhow. And then 7 times 7 is the n, the b squared, 49. So y times y squared, y times 7 times 2, that's our 14y, 7 times 7, 49. So that's how I'm going to do the rest of these, and I really, really encourage you to just get this little piece of math down. It will help out in a bunch of different spots. So here, this first one, we go 3y times 3y, so that's 9y squared. 3 times 4 would be 12, times 2, we're just going to double it, so that's 24, and it takes the sign of whatever's here, so negative 24y, that's our negative 2ab, because this is a and this is b. And then b squared, so 4 times 4, 16. And it's always a plus on the end because you're multiplying this, you're squaring the sign. This one, so x times x squared. X times 9 times y, or sorry, x times 9y, that would be 9xy doubled 18y, xy, excuse me. And then 9y times 9y makes plus 81y squared. And then this next one is an a plus b, a minus b. So remember, those make a squared minus b squared. So this one is the one that everyone wants the other type to be. But this one really is just 9y squared minus 25. But there is no 9y squared plus 25 version. That's the, you either get the 3 terms like we saw, or the kind of the minus. So this is just the difference of 2 of those kind we were just working on. So this would be 2y times 2y, so that's 4y squared. 2 times 3 would be 6, and then doubled would make 12y. And then 3 times 3 makes 9. And then minus, and then anytime we subtract, remember we need that parenthesis. So y times y squared. And then 4y doubled would be 8y. 4 times 4 makes 16. And so it's really nice if you don't have to break out and FOIL all that, put it together, FOIL all that, put it together, if you can just kind of do it in place. And then I'll go ahead and show the sign distributed, just because I think I mess people up if I don't. And then collect terms. So 4y squared minus y squared, so that's going to be a 3y squared. 12 minus 8, that's going to be plus 4y. And 9 minus 16 will be a minus 7. Okay, these last 3 are from 4.7. I just rewrote them so the exponents would be a little bit bigger. So remember, the trick to these is they cancel to both terms. So canceling here doesn't mean this is gone. It still belongs here just as much as it does. And if it helps you, write it as 2 separate fractions. I'm going to skip that step just because it kind of gets big and messy. But negative 5 into 15, so that's going to be a negative 3. And x cubed over x squared, so that's going to leave an x. Y squared over y, so that will leave a y. And then on this next term, negative and negative, so that's positive. 10 over 5, so that'll be a 2. x4 over x squared, so that's x to the second. Y cubed over y, so that'll be y squared. For number 2, we got double negative to start, so 35 over 7 will be a positive 5. x4 over x3, so that's going to be an x and then that y. And then here, whoops, don't mean the plus, plus and minus, so that should be a minus. And then these are identical, so they don't just disappear. Remember, 7 divided by 7 is really not nothing, it's really a 1. And then this is the third one. So here, that 9 and the 15, so this is going to be, maybe I will rewrite this one, just to show that canceling a little bit better. And then plus and minus, so I'm just going to write minus right there. And plus and minus again, so I'm just going to write minus. So here, I can cancel a 3 out of both. So 3 would go into 15 5 times, and 3 would go into 9 3 times. And then I have x squared over x cubed. So that's going to leave me an x downstairs, and oops, y squared right there. So y squared, so y downstairs. And then here I'm going to have minus 3 over 9, so 3 goes into the 3 once, 3 goes into 9 3 times. X cubes cancel, y cubes cancel, so that's just a big old 1, so that's 1 times 1/3 or 1/3. And then minus 18 over 9 makes 2. X4 over x3 will leave an x, y cubed over y squared leaves a y.